Here is an Icom IC25A that I picked up in non-working condition supposedly at a Hamfest this last summer. So it's been sitting here. I thought it was about time I take a look at it and see if I can figure out what's wrong with it, or whatever's wrong with it. So 146.52. Well, here's a look under the hood. It's like the receiver section. It's got a ComSpec PL module here. It looks like an aftermarket. It's looks like it's taped to the top of this processor here. Nothing looks visibly bad here, but let's flip it over. Okay, the transmitter module's in here. I can disconnect the exciter. Here's a connector here to do some tests. I probably have problems in the exciter here, so I guess one of the next steps, since we know the exciter's working, the receiver's working fairly good, I guess the next step is to open up, look at the transmit module and see if we can find out what's wrong with this thing. I don't have a service manual for this yet. I'll have to look on the internet. I'm sure they're available, but yeah, this looks like pretty straightforward circuitry from the time. These are well-made radios. I always like these older units. So I guess we'll have to dig a little deeper to find out why this thing's only putting out what was it, 27, 28 milliwatts. Looks like the exciter's okay. The problem's in the power amp in this, under this heatsink, under behind here. You can see where the coax leads the output of the exciter, looks like here, and the input here to the power amp, and the power control comes in this connector, and there's a large heatsink, and so the transmit section's behind here. So that will be our next step. Okay, here's the PA unit here, and it uses a little power brick here. It's an Icom number SC1019. So not sure where the problem is, but if this is bad, that may be hard to find one. And of course you got to be careful, because a lot of the replacements turn out to be fake parts. So we'll check it and see, make sure it's getting voltages and make sure the input's okay, and go from there. Well, I've done some troubleshooting and I found, unfortunately, it looks like the problem is the PA module here. This is U1 or IC1, which is a hybrid power module here, and the exciter on the main board, J3, this connection right here, is the output, and it feeds the input here. Now on the diagram you can see the J3 feeds pin 1, and I am getting 3 volts RMS here. I measured this with a high frequency scope that goes up about 400 megahertz, so I know I'm getting input to this module. I have supply voltages supplied, and it's being switched here between high and low power, so it looks like this module is bad, which is the SC1019. On the diagram here you can see, here's J3, this is the connector here that connects to the power module. J3 is right here. So other than buying a new power brick, or whatever you want to call this thing, IC1, the SC1019, what I think I'm going to do, since I have nothing to lose, I'm going to pull this unit out, and I'm going to pull the cover off of this, which exposes the substrate. That's some type of a ceramic substrate on the bottom. There's a heat sink here, and I'm going to take a look and see if I can find anything that looks out of order. Other than that, there are some of these available, but I think they're probably pulls and they're from China, so I don't have a lot of faith in ordering one of these. Anyway, that's the next step, is to pull IC1, pull the lid off of it, and take a look inside and see what we find. Okay, I've removed IC1 from the transceiver, which was not a fun job. I don't suggest you do it, but anyway, this is the transmit module, and here's its innards in all its glory. And looking on the microscope, as I can move it around under the microscope, and you can see as I move it, we can observe the components on the ceramic substrate. What I'm looking for is any signs of damage or possibly a crack in the ceramic here, which is a known problem with these things. You know, they get hot, they're on a metal heat sink, and with thermal cycling and temperature extremes here, especially if you're running it at high power, these ceramics tend to crack, and that doesn't look good, that point right there. Oh, now that almost looks like a crack across there. Okay, we'll have to check that. Okay, here's the board here. I'm going to check this with a meter here set to continuity, and looking at this, let's check this section here. Look at that. That's open circuit. Okay, right here, here's a crack. This side, there's no continuity. And this side, there's continuity. Now this is okay. So what I'm going to try to do, I'm going to try to close this gap here. With a small wire. And I think I'll put one across here too. And let's see up here. This looks like there's a crack just about to start, but no, it's still making contact. And there's where we're open. So moving along here, you can see we're open circuit till we get to this crack, and then we cross it. Continuity. So I'll have to find a fine wire, bridge the gap across here, and then it looks like this one's ready to open also, so I'll bridge here and here, and I'll check this out. What I'll try to do is get a fine wire and maybe run around here. I may change, there's some type of impedance this is used here. I don't know if it's some decoupling. I'll have to look where the power comes in, but whether adding a wire here is going to change it, the impedance, which will cause a problem, I don't know, but it's worth a try because this unit isn't working. So that's the next step. Bridge the gaps in this here. And looking at the rest of it, I don't see any other points that appear cracked. That does, I don't know, that looks a little fishy there, but that's hard to tell. Here's the main transistor right here, you can see. And this must be driver. I don't know if these are little bond wires or what they are in here. They seem to go, using the meter probe here, they seem to go to these pads here and here. So I don't know. This looks like interesting. Anyway, that's the next step. Stay tuned. Okay, I've magnified this further, and I'm going to take a needle and show you the point where, if I can get in here, a little difficult. Anyway, here's the point of a pin, and that's where the, okay, that's a pin. You can see the tip of the pin, and that's where the break in the circuit board is. Now if you look to the right here you can see a crack in the ceramic substrate. It runs here to here. There's a crack. Okay, so this PC board material, which is ceramic, and there's a trace on here, and here you can see that it's a little hard to see here, but it looks like there's a crack forming here too. So now I could probably touch some solder on here, but the problem is it looks like this is feeding the power to the output transistor, so there's going to be a lot of heat in this area, and that would probably open up again. So let me move out here and focus, refocus. Okay, here's the power coming in here. This is the output right here. This goes to the changeover. I think it's just a pin diode. I'll have to check it out. But anyway, this is the output. And this is the power following this pin. And you can see along here, here's where the crack is. And it's feeding, I'm assuming, the collector of this transistor here. This is the output power transistor. So the power is fed up through this. This must act as an inductance to decouple the power from the output. The output, of course, comes out in this direction. And here's a coil. And then the output is connected here through this bar. And then there's it looks like a cap coupling it to the output here. And then looking back, here's the driver, the transistor that drives the output. And of course, fingernails. Here's the input comes in, I believe. This is a little questioning here. Here's a coil and a ferrite bead, it looks like. Some type of decoupling network. I don't know how much this crack is going to progress. I may try, well, I'm going to try this. I'll try bypassing across here. Here's where the actual open is, and I better do it here too, because this crack is probably going to progress to the end here. And this transistor is going to get really hot. The output of this transmitter is 12 25 watts, but I'm going to crank it back, maybe have a maximum power output of 20 watts. Anyway, next step is to repair that crack. Okay, I'm about to do surgery on this thing. In case anybody wants to watch the procedure, first I'm going to apply a little bit of flux onto the area in question. And what I'm going to use this is a piece of telephone wire, a small gauge. Here you can get an idea how big it is. A little bigger. I wish I had something a little smaller, but that's it. So what I'm going to do, warm up the iron. I'm going to tin this wire. I'm going to make sure I bridge that gap. This has to lie flat. I guess that'll work. Maybe. Let's get a little rosin. I don't want to get any under that transistor if I can help it. And that's where the break is. I'll try to clean it a little better this time. Make a loop like I did on the other one. And I try to get it in the frame there. That's kind of close, I guess. A little more of an angle here. Oh. Shit. Alright, let's try this again here. Put a little solder on the loop, and I'm hoping, I gotta make sure I'm over that known gap. Oh god, it just doesn't want to. Don't look. I know I shouldn't do this, but I don't know how else I can get enough heat on there and in a short amount of time. Well, it might be ugly, but the question is, do we hear the beep? Let's try it. I guess that's a good sign. Well, it doesn't pass for pretty, but it passes for continuity. I'll try to clean it up a little bit. Get some of that flux residue. I know this is going to get really hot. Hopefully the solder will hold. I guess time will tell. I wish I would have gotten this a little closer here, but it is covering the gap. I'm going to look at that a little closer. I don't know, this is going to be a big question mark. Okay. Here's where the crack was, right? Let's see if you can see it. No. Is it right in here? Anyway, it looks like it's bonded here good and here good. And this wasn't a problem, but it does seem to bond over that other area. So focus this thing here. I'm going to give it one last continuity test. There. I think that's the best I'm going to be able to do. Now we'll just have to try it and see what happens. So I'm going to put it back together and we'll give it the smoke test. Maybe some real smoke. Okay, the output power module is connected back in. I removed the circuit board, redid a couple solder joints. It didn't look really good. I checked this electrolytic, it's good. I checked the ESR and the capacitance, it's within tolerance, no problem with that one. And there was 4 leads here I had to solder to the posts. Redid the heatsink compound. If this thing works, I'll put the lid back on, the cover, and then there's also a shield that goes over the top of this unit. So I guess now it's time to put it back together on the main part of the transceiver and see what happens. Cross my fingers. Test 1 2. 1 2 3 test. 1 2 3 test. Well, what do you know? It worked. Testing 1 2 3 1 2 3. Test 1 2 test 1 2. Hello test, hello test, hello test. 1 1 1 1 1. Okay. Well, I guess that's a fixed one. My last one didn't work out so good, the Philips oscilloscope, but I'm glad to say this one did. And it just turned out to be the cracks in that trace on that power unit, so that power module. So if you have a transmitter like this and you have very low or no power output, you might want to pull that power module out and check for cracks, although it wasn't a real fun job. And if you do it, use a real hot iron if you can do it. That didn't want to take solder very good. Okay, here's the test here using the service monitor. Hello test, hello test. This is low power, 1.2 watts. This is high power, 23, 24 watts. That looks good enough to me. Anyway, it looks like this unit is fixed. So, anyway, that's it for this one. Thanks for watching.